Here's another example of the mean value theorem taken straight from an AP exam, multiple choice question. Please take a moment, read over it, and answer what you think might be the correct solution. So, here's why it's not part A. Part A, the minimum value on this function is 2. And obviously, if we look at the table, the smallest number is 2. However, this is only 5 points on the entire function. It's not showing us the infinite number of points that are in between. Maybe this graph is going down here, all the way down to -1 million, and then back up to a height of 3, just between 0 and 1. It's not likely, but there could be a dip that goes that low. And so if we don't know what's happening between x equals 0 and x equals 1, and we don't know it goes way down below, or maybe between 1 and 2 it goes way above, or vice versa, we cannot predict what the minimum or maximum values will be. A and B are false. They look good just from those 5 points, but they're false. Next up, we don't know if the function's always greater than 0, because once again, we don't know what's happening in between those. It could dip down much farther below 0, and we wouldn't know it because we've only chosen 5 points to represent this function. Same thing about the slope. The slope certainly looks negative. We're going from a height of 4 down to a height of 2. I know the average rate of change is negative, but I don't know if every point on there has a negative slope. There could be some twists and turns. Which brings us to the mean value theorem. There exists some x value between 0 and 4 for which the instantaneous rate of change is the same as this average rate of change. And the average rate of change between these 2 points of the same height is 0. Therefore, the correct answer is E. If you chose E, good job. A little pat on the back. Last example, this was also an AP question. All of them dealing with several of the existence theorems that we have learned to this point. Please take a moment, pause your computer, and try and answer this question. Okay, first off, we're saying there exists a number where the slope's 0 between -2 and 1. How do we know that? Seems the average rate of change is positive. In fact, the average rate of change between these 2 points would be going up 9 while the run is 3. That would be a slope of 3. We don't necessarily, that's not even the derivative there. That's the actual point. And we do actually know that there is a point at 0. That's the intermediate value theorem, the IVT. If it's continuous and differentiable, you got a negative point and a positive point. It must cross everything in between. The second one was the one I was just describing. How do we know if the slope is 0 between there? We don't. We have no way of knowing that. When we take a look at C, once again, this is the intermediate value theorem. 1 point's at -5, one is at +4. There must be a height of 3 somewhere in there because it is continuous. We also know by the mean value theorem, if the average rate of change is 3, there has to be at least 1 point where the instantaneous rate of change is 3. So by the intermediate value theorem, A is true, C is true. By the mean value theorem, D is true. And now what about this last one? Do we know there's a maximum on here? Sure, that's the extreme value theorem. If you have a continuous function on an interval, there has to be a maximum and a minimum point on there. Even if they share it with another one, there's got to be at least one max and one min. So we have 4 existence theorems up here and one which doesn't quite fall in any of those categories. B was the correct answer. That is the solution. Thank you.